Thank you for choosing DiQual, and welcome to our podcasts. Before we start, please don't forget to like, subscribe, comment, and share. It is really important to us. Hit that notification button as well, because there is more to come. You can get more detail about DiQual and our courses on our website at www.mydiqual.com. We hope that you enjoy this one.
This section is Security Practitioner 205, System Network Infrastructure, and this is Common Network Devices.
Layer 1 Device. Hub. A passive network hub is the most basic form of common point network connectivity for multiple devices. Unlike Layer 2 devices, a hub has no routing tables or any intelligence about where to send data. A hub does not have an IP address. Instead, it broadcasts data across every connection. All data received on one port will be automatically passed to all ports. Hubs tend to be a lot slower than Layer 2 devices. However, even though they are Layer 1 devices, many hubs are intelligent, in that they can detect basic network errors, such as packet collisions, or monitor the data passing through the device. In the past, hubs were a popular choice for networking, but with Layer 2 devices being significantly cheaper now than they used to be, hubs are not so popular. They are suitable for smaller systems, but they can create excessive data on larger ones. Layer 2 device. Media converters. A media converter is a network device connection that changes one data transmission method to another. Media converters support different protocols and different cabling types. Cabling may be Cat5 or 6, twisted pair cable, coaxial cable, or fiber optic cable. Therefore, for example, media converters may change UTP to coaxial transmission, or coaxial to UTP. Another example would be fiber optic transmission to UTP, or vice versa. Media converters can also modify duplex and speed settings. Switching media converters facilitate the connection of network segments that are operating at different speeds. For example, older networks can be connected to new networks, and extended with faster technology. The different transmission media that are used within a computer networks have different characteristics and properties. The basic property of each is the distance that it can be used to transmit data. Cat5, E, 100 meters max, 1 gigabits per second. Low cost, easy to install. Coax, 1 km, 100 megabits per second, often used for existing CCTV infrastructure. Fiber, bandwidth, 120 kilometers, 10 gigabits per second, more expensive, specialist installation. Media converters can be used as standalone devices and used in pairs, to offer conversion between media, or used to connect directly to equipment with different media types. Media converters with more than 2 ports are effectively unmanaged switches, which can also convert different media types, allowing a daisy chain topology. Many media converters sit in Layer 2 of the OSI model, because they can transmit data from point to point, with some intelligence. Devices on this level sort packets of data using physical network addresses, i.e., MAC, which is a unique number that is assigned at manufacture to all devices with a network card. Media converters residing in Layer 2 usually have more than one port in and out. As with switches, devices operating at Layer 2 are fast, but lack intelligence, as they take limited interest in the data packets. By monitoring the MAC address information, switches can learn the whereabouts of attached devices, and only send data destined for those devices, out of the ports on which they are connected.
At this point in the text is a picture of an industrial, rack-mount, media converter.
Some media converters have additional features, such as link fault pass-through, LFPT, which is a feature that enables a media converter with a failed copper link to report this to the remote media converter, which in turn will disable its copper link, ensuring that the connected switches are aware of the failure. Without this feature, a failed copper link from a media converter to a switch would not be highlighted, and will continue sending data.
At this point, there is a diagram that shows how a fault at one end of the network will trigger the disconnection of the other, to ensure that the connected switches are aware of the failure.
The find fault feature enables a media converter to disable its copper port upon loss of Rx on the fiber link, at the same time informing the remote media converter of the fail, allowing it to also disable its copper link. This feature also ensures that the connected switches are aware of the link failure. Without this feature, switches would be unaware of the failure, because the link between the switch and the media converter would still be active.
Here, there is a diagram that shows how a fault on the fiber optic element of the network will be communicated to the connected switches, so that they are aware of the failure.
When selecting a media converter, there are some features that are a huge benefit to network design. For example, the environmental conditions at the installation location may require either commercial, industrial, or a hardened specification. The following is a list of considerations when designing a network using media converters. Which media requires converting? Ethernet, coax, fiber, alarm cable, or serial. Data speeds required. Fast Ethernet, gigabit, etc. Number of ports required. 1, 2, 4. Media converter technology. Unmanaged or semi-managed. Is PoE, power over Ethernet, required? 15.4 watts, 802.3 AF. 30 watts, 802.3 AT. 90 watts, 802.3 BT. Is a power supply required? Hardened media converters. Commercial media converters. If using fiber optic cable. Fixed fiber, or SFP, small format pluggable, ports. Multimode, MM, or single mode, SM. Number of fibers. Fast Ethernet or gigabit data rate. Transmission distance. If PoE, which power supply is required? It should meet the maximum PoE capacity of the host device. For example, a 120 watt PSU could be considered for a host device that may take up to 10 watts with 110 watts remaining for PoE delivery.
At this point in the text is a picture of another industrial, rack mount, media converter.
Layer 2 device. Network switch. A network switch is a device that connects other devices together on a computer network by switching packets of data to receive or forward to a different destination device. Switches offer efficient and intelligent data transfer when compared to hubs. By paying attention to the data arriving on each port, a switch can learn where particular devices are located. For example, if traffic from machine A arrives on port 2, it knows that machine A is connected to that port. Traffic destined for machine A, therefore needs only to be sent to port 2. The benefit of using a switch is that most of the network traffic is directed to the port on which the receiving device is located. On busy networks, this can significantly improve network performance.
That completes this section of audio. We try to keep narration short, because there is a lot of information contained in this section. If you want to, you can listen again, or read the section and switch between text and audio. When you are ready, you can proceed to the next section or subsection within the module.